Okay, so we are recording now officially. All right, we'll get going. It's about 7:10. And my apologies, I'm running a little bit late tonight. It's just kind of, I'd love to blame the weather, but that's not the case. So you're all very welcome to this. I think it's the 5th in the series of the Dublin Data Science workshops on data science soup to nuts. So before we begin, I'll just do a quick thing. Dublin Data Science is a meetup group we've been running since 2017. We were all kind of part of a few other meetup groups prior to that, though, from about 2013 or so. So we talk about stuff in general. Like a lot of work I do is in R, but we have had talks about Python, Julia, a few different ones. We're kind of very generic. If any of you here in the audience, you're all, thank you all for coming. If any of you are interested in giving a talk at some point to us in the medium or near term future, we're always looking for speakers, and our usual pipeline of that age-old joke of like basically accosting people at the bar after our in-person talks has dried up, obviously, under COVID. So we're always looking for speakers. By all means, please reach out and like give me a shout, either after this talk or an email or through Meetup or GitHub or LinkedIn, whatever channel you have. We're always happy to have speakers. We usually try to have one event a month, and in COVID, sometimes we would have more because the workshops would be kind of in parallel to the talks. The way that has kind of transpired is under COVID, it's been much harder to get speakers. So we tend to have one talk every maybe 3 months or so. We do have a speaker lined up for September. The details aren't organized yet, but it's one of my friends from London who will be giving a talk on boosting. We had a talk about, I think, the inaugural Dublin Data Science talk back in 2017, which I missed because I was in London. Was on that, so he's been doing a bunch of work, so I think that should be quite interesting. But anyway, that's not why you guys are here. You guys are here for the workshop series. So rather than a speaker, for those of you actually, rather than just make assumptions, if people wouldn't mind, would you mind popping into the chat too, for how many of you are here? Could you give me 2 pieces of information? One, what country you're from, if you're comfortable sharing that, or even just not Ireland. But also if you've been to any previous workshops in this series or Dublin Data Science workshops in general, if you wouldn't mind just popping into the chat, just so I have a sense of like if people are familiar with this format and how much basically I need to go into. I do see a bunch of new names, so I mean I'm going to go back to the way we're going to format this is essentially the first probably half hour or so. Well, it's 4:15, maybe a little bit longer, up to maybe 20 to, will be based on just summarizing the project as a whole and where we've got to at this point. And oh, excellent. Okay. Oh, hi, Raphael. I thought that was you. You're very welcome. Good to see you again. Oh, okay, great. So we've got a bunch of people who are on the relevance, and some of them, wow, okay, someone's watching them on YouTube. Respect. That's great. So basically, what the genesis of this came from a couple of conversations we'd have after various meetups, almost certainly in the pub. I can't quite remember them because I think it was kind of a mishmash of a few. And it was basically the difference between what a real life data project looks like and kind of the perception of it that you might get from Kaggle or courses online or any of that kind of stuff. And we were all very conscious that no one had really covered it. So I thought, well, I'm always looking for reasons for running workshops and for various topics. This seemed like a good one. And then once COVID hit and all that, we were kind of stuck indoors anyway. And I used to do them in person, like upstairs in various pubs, wherever we could get venues. But actually, one of the benefits of COVID have shown is that the in-person talks definitely need to be still done in person, I think. But these kind of work, there's no reason not to run these workshops online. You get a bunch of benefits, like we can record them and stick them up on YouTube later on, and they become a reference. But also, it allows you to get into a bit more depth, and you know, it's just a lot less hassle for everyone. So basically, what this series has tried to cover is a data project from the very start. And then the very first workshop, if you look it up on YouTube, we go all the way back to basically finding the data set online and like downloading it and writing code to download an Excel file and then load it up and check that the data loaded properly and look at what the formats were and just see what we had. And the other motivation for me was that basically as a way for me, I mean, one of the reasons I run these workshops and I enjoy them is because I usually use it as an excuse to learn something. So there's a bunch of like esoteric topics we've covered in the past. And most of the reason was I thought they were kind of interesting and maybe they weren't particularly well known outside of their certain areas. And, you know, they would be very standard in some fields and completely unknown outside of that, even though they'd be just as applicable. So, you know, a lot of work in machine learning and this data stuff is driven largely by the retail sector. I mean, realistically, an awful lot of the big work that has been, you know, B2C businesses essentially selling you stuff or selling you advertising. I mean, one or the other. And there's been an awful lot of work done in the retail space using this kind of data. So I had heard about a few different things, and the idea of working with a retail data set was quite interesting. So that was kind of what we went with. So the other thing I was going to do was learn a few things like Recency-Frequency-Monetary modeling, Rfm modeling, and vital UDI modeling. Now, as it turns out, and I will talk about this later today, we're probably not going to cover vital UDI as much as I was expecting at the start, for a couple of reasons. One, it's actually much more in-depth and interesting than I thought it was, and I'm going to use that as the main topic of my next workshop series, which will either be later on this year or early next year, depending on how this series goes. But I'm going to use it in a Bayesian context for vital UDI. So I'm going to discuss Bayesian vital UDI modeling and use Bayesian approaches to it, which I think will be quite interesting. So yeah, so that was kind of what we've looked at. So the thing I wanted to talk about mainly was like just how far you can go with relative simplicity. You don't need like high-end stats knowledge. You don't need, you know, fancy modeling techniques or analytic techniques, or even necessarily high-end programming skills. Although the better a programmer you are, the better you, like, that's a basic skill of the job. So the better you are at programming, I think the better positioned you are. But like, you don't need to really understand fancy modeling techniques and all these different like supervised and unsupervised techniques to get something useful out of the data. And in many ways, actually, simplicity is a strong point because it's much easier to explain to non-technical people. So in the first like workshop, it was literally just get the data, look at the data, do some basic exploration. The second workshop was a lot of time spent on basic data exploration. We kind of covered it in the first one, but we spent pretty much all of the second one on data exploration and modeling and looking at stuff and, you know, trying a few different things out. The third one was we started looking at modeling and like basically not, and this is something I kind of wanted to capture, because when these things get presented online, they tend to get presented as a fait accompli, where you kind of go through from start to finish and, you know, you present things in a very linear fashion, what you did and how you did it and what gets done. And to me, that's a very inaccurate representation of how these things work, because in reality, this is a very messy process where you go down a bunch of blind alleys and you just try a bunch of things out and you see if it's going to be interesting. And I've yet to work on a project where I kind of knew at the outset where things were going to go, because a lot of things are dictated by the data itself. So you could get one data set that you've already worked on, like something similar in the past. So you get the new data set and you'll find it's different, even though it's like in the same sector and it's a similar type of business and it's a similar time period and all of that stuff, but they'll collect data in a different way, or their marketing focus will be different, or while there will be superficial similarities between the two lines of business, they will have subtle differences that have a massive kind of butterfly effect in terms of how you approach. They may even have they could have everything similar, but very different strategic goals. And that will affect how you model things. So what I kind of wanted to do was take all these ideas and just kind of show essentially the messiest, show it kind of warts and all. And the idea from soup to nuts is it's an old English expression that you started a meal with soup and you finished with the nut dessert. Like after the sweet, you would have some nuts and cheese or whatever. So it's like from start to finish. But I prefer the term soup to nuts because I think it stands out a bit more. So yeah, so that's essentially what this project is about. So today, what I'm hoping to do is I'm going to do a quick summary of where we've gotten to so far, because like everything else you probably guessed, context is king. So I am basically going to present it the way we kind of format. I am keeping an eye on the time because I don't want to just blather on about nothing. We'll probably go through till about sometime around 8 o'clock, and that might be 10 to 8 or 5 past 8 or 10, be say plus or minus 10 minutes, purely because it's good to take a 5 or 10 minute break. Everyone can run to the toilet, or we can just, if there's any kind of longer form questions, I can address them in the break or at the end. There's a very natural break point there. It gives me a break on my voice as well. I have a big mug of tea here, which I'll use to lubricate, but and I'll take a sip in a sec. And then depending on the natural break point, we'll take the break. And then when we come back after that, we'll run through till usually 8:45, maybe 9 o'clock, just again, depending on how far we've gotten along, whether or not it's worth starting a new topic. Like I have no problem if it means I let everyone go early at 8:45. Invariably, there's a bunch of questions or people have kind of longer form discussions. So that, it gives us an idea to that without keeping people here all night. So that's basically the rough running order on that. Before we begin, since we do have an awful lot of repeat customers, which is great to see, by the way, and it's great to see a bunch of repeat names. If any of you have any questions, pop them in the chat. I'm happy to discuss them, and I am happy to kind of chat about them. Like, for those of you who aren't familiar with the format, like I want this to be as discursive as it could be with me talking at a screen. So I am keeping an eye on the chat, and like I said, I have Neil on standby here, who is one of the Dublin Data Science regulars, just keeping an eye as well. So if I miss something because I've gone off on one, like he can kind of rein me back in. And yeah, so what I like, even if it's something that's only tangentially aware, by all means ask me. I'm happy to talk about this. If we go off on a tangent for 5 or 10 minutes, I have no problem with that, especially if sometimes it's more relevant than you might think, but also if it's completely like out of left field or distracting from the current topic, we can just address it at the break or at the end. So I'm more than happy to like keep this running. By all means, just keep me posted. Now, the idea for the series was laughably to have like I figured it might be 4 or 5 workshops. That clearly has failed miserably. A bit like J.R. Tolkien. It's a story that has grew in the telling. But to be honest, I'm okay with that because, first of all, people keep showing up. Although I'm not entirely sure I even care about that, because I'd end up recording to myself and then throwing them up on YouTube later, because I think this is a useful resource to have. And I wasn't sure if anyone would look at YouTube, but we are actually getting views, and we do have someone here who actually says they watch them on YouTube, so which is great. And I know a couple of other people who don't appear to be here tonight that do definitely catch the videos. So yeah, I'm more than happy to just keep going, because I think it's an important thing and I would like to finish it. So tonight we're going to cover essentially kind of the more what are called RFM models and bite-till-you-die models. And again, probably bite-till-you-die not as much emphasis, even though they are probably more important than RFM. And again, it's just kind of feeling our way out what we're going to do. What I would like to do then is maybe the next workshop will be, having taken the last kind of 3 or 4 workshops to figure out what the hell it is we're doing, do it, that kind of decide on something, do the modeling like the proper, it might be just copy and pasting previous workshops, but do something with a bit more structure to it, rather than just a random bunch of, oh, this seems like a good idea, which, like I said, I still wanted to include because it's a crucial part of this process. But then at some point, and it's usually towards the end of the project, you kind of go, all right, we've kind of dicked around with this data enough. Let's just, let's just get something done, because, the people who are paying us are going to expect some kind of results. So we're going to kind of take the idea, and I have a rough idea what I think I'm going to do in that one. Again, that might, and I do get ideas from you guys as well. So this is also partly, like I said, a back and forth. A bunch of good ideas came from the people here in the first couple of weeks, in the first couple of workshops. So if you have ideas that you think I'm missing something obvious, by all means, give me a shout, and we'll give it a rattle. So what I'm thinking is, like, this will be the last of the kind of what I'd like to call the model exploration, where I'm trying some stuff out. Next week, next month, or whatever, next workshop, what we'll probably do is essentially, having decided or discussed it this week, after this workshop, figure out what the modeling is going to be. And it might be and it probably will be a combination of a few of the workshops in the past, come up with an answer, and then that's going to be kind of the focus of the next workshop. And then the final workshop is probably going to be the most important, which is going to be like model presentation and discussion and outcomes, and what have we done, lessons learned, and essentially thinking in terms of presenting it to a non-technical audience, or at least a semi-technical audience. I mean, depending on how you want to go it, in terms of how simple you need to boil down the message. And I think it's something we typically, like data people, are bad at. And it's very easy to dismiss non-technical people as just being stupid. But the reality is their skill set is very different. And as any number of startups will tell you, this being successful is not just about having good technology. It also, you need to understand the business and commercial relationships and all that kind of stuff. And so you will, as part of your, like, if any of you are involved in this, certainly as part of your career beyond just for an interesting thing in the evening, being able to learn how to communicate with people who don't have your technical background is really important. And essentially it boils down to just being simple, like coming up with simple messaging, like if you've got a couple of takeaways from the project, and this might be, in this project, it might be just, here's your important customers, or here, for whatever definition of important, like here are your most loyal customers that have the highest essentially long-term value, or these are guys we're in danger of losing, or these guys we should just pay no attention to at all because they, you know, they're going to churn, or they have churned, or there's no point wasting any time in it. So, you know, looking at that, and also maybe I'm thinking, you know, what types of products do those valuable customers buy, and maybe, or maybe what might they be interested in, and how do we target them? So what I'm thinking towards the end is it'll probably be a relatively simple message, and give them something that people can say, you know, that marketing buzzword of actionable outcomes, which is a terrible phrase, and I probably should, you know, do myself some damage for uttering it. But the concept is important, that you need to give, you can't just give people a whole load of like model outputs and tell you, here you go, everything you need is right there. What you need to be able to do is boil things down to a very simple message, down to a single page, and you know, and get things done. There's a very good scene in the movie Margin Call, which is actually one of the most realistic representations in my experience of the capital markets, because it's not all just cackling the evil people. It's a bunch of people who like each other and make a lot of money, but do actually work for a soulless corporation. And, you know, senior management do tend to be sharks. But there's one great bit where the very senior guy flies in, played by Jeremy Irons, and he goes, and let me explain to you, Mr. Sullivan, speak to me as you would a 5-year-old child. I can assure you it wasn't brains that got me here. And it's just a very good, it's a very good scene. But that's kind of, I always think of that guy, because he's the guy who has the power and makes decisions. He's ultimately the guy you want to impress. How do we get the communication message to him? So that's kind of where we're going to be focusing on after this workshop. Okay, so that's me blathering on, and it's already 7:30. Bloody hell. Okay, right. So very quick summary of where we got to. So we got a whole load of retail data. I'm just quickly summarize it. This is what came in the Excel spreadsheet. So all it was a list of an invoice ID, which was a string, like a character ID, and then a stock code, which was some kind of random string of mainly numerics and then of digits and the odd letter, and then a free-form description text, and the quantity, the invoice date, as in the date of the invoice, how much price was paid, and what the customer ID was. So it's a big long list. As you can see, there's a million rows in it of transactions. So it's basically purchasing behavior for a customer. We have no other information on the customer. We don't know a customer name. We don't know gender. We might know the country, because that country there, but even that isn't hugely reliable. But we know the timestamp. So we don't actually have very much. As you can see, there's 9 columns there. Actually, there's 8 columns in the data we got. Excel sheet is something I added because the spreadsheet came in 2 tabs. And that was one of the lessons we learned. If you go back and watch the YouTube video, I didn't actually pay attention to the fact I didn't open it in Excel, even though it was an Excel file, which I probably should have done, because it just didn't occur to me to think of multiple spreadsheets, like multiple worksheets. So yeah, so we did that. We looked through it. We did a whole load of data cleaning, and we just, you know, did some data, created some time of days, created a whole load of things. I'm not really going to go to check for missing data. We did some univariate ones. We looked at, like, is there logical variables, whether something is cancelled or not, you know, a bunch of derived variables plotted on a normal scale and a log scale. There's some return data in there, so we had to parse. There's a bunch of other weird things like account transactions and bank fees and Amazon fees and gift card sales. There's a whole load of things in here as well that were just kind of, what the hell is this doing in here? Because the other thing that the disadvantage that this project has is the data we got from the UCI machine learning repository and we don't really have a whole lot of context, and we don't have a lot of explanation. And most importantly at all, we don't have someone we can go to talk to who understands the business or the systems that this work was on, which is usually crucial in a project. So we are working to a certain extent with some disadvantages. But the one thing I've been very pleasantly surprised at is even such a simple data set you can get a lot of very interesting insights from it. So we did a whole bunch of stuff, and then we went into some custom explorations. We looked at some time series data. We looked at some graph data. We did a whole bunch of things. We looked at, the line plot, the total spend by day, so you can see if there's some kind of seasonal patterns. We noticed that there's a few days where there's no trading at all. Those are around Christmas. So even though it's an online business, it looks like they shut down for the Christmas holidays. So we kind of learned that from the data, because it kind of finishes around, depending on the year, there's 2 Christmases in here, 2, because it ends just before the second Christmas period. You can see there's kind of, 10 days the business shuts down. It shuts down, like, it goes from, like, say, the 23rd of December to the 4th of January kind of thing. So typically there's like about 10 days, 10 calendar days roughly. So we did a bunch of things, did some line plots, because just to emphasize again, we didn't really know what we were doing here. We had gotten a bunch of data, but we didn't really know whether it was going to be useful or not and what would be good. We didn't really know what we were going to model. I had a few ideas of things we could try out, but I didn't really have any ideas beyond that. So I kind of went to some of my old stalwarts of my background is time series analysis. So I created some time series of it, of like total spend. We could do that by maybe customer cohort. There's a bunch of things we tried just in basic exploration. We didn't model anything here. Investigated the refunds because, refunds are important. As it turned out, we haven't really focused on refunds as much because the data is problematic in terms of there's no, when it was a refund, it appears to be just put in, but it's not linked to the original purchase ID. So we have no real way of linking things up beyond like checking the customer ID and the price and making sure it was after that date and then returning it. But there's not always a perfect match up. So we were discussing, like, I got myself, like, this is a classic do as I say, not as I do moment. I caught myself basically overcomplicating and over engineering it. And I started thinking about like popping them off a stack. And, when a purchase at a certain price, add it to the stack and then pop off the stack when there's a return. And then kind of what you're done at the end is the kind of the net transactions. And at that point I went, oh, hold on a second, Mick. Do you need any of this? You've got a bunch of work done. It's something you should pay attention to. You've actually done a bit of work on it, which you also stop because I'm not sure how much bang you're getting for the buck here. Now, it is important because there was a few clearly errors and stuff. But anyway, what we're just kind of doing is effectively ignoring it for the purposes of these models, simply as an expedient thing. In the long run, you would go to the thing and try, and they would have a sense. You'd probably look it up, but I imagine you would have better data. If I was doing this as on a consultancy basis, I would probably at some point, depending on the time of the project, if we had the time and it was important, I would probably go back to it after this workshop. But for the purposes of teaching and all that, I'm not going to do it for this. So then I've added, now this CAS came in recently, we have looked at essentially vital you die modeling and recency frequency. So I've kind of taken the data and I've, compressed the transaction data down, which is this one here. I've gotten rid of all where the quantity is was greater than 0. And we also did some cleaning out in terms of excluding things like where it was Amazon fees or bank fees or something basically that wasn't a direct transaction, but was in the transaction database. Excluding returns and a bunch of other things that just didn't seem to be that were kind of in there and that we had found as a result of our explorations. I kind of changed that to exclude equals true. So I'm just filtering all them out and all the returns are out. And what we left is just under 1 million transactions. We have a stock code, we have a customer ID. And now what I'm doing is just aggregating. So, if a customer on a certain date has more than one invoice, so the first thing I'm doing is aggregating down to the invoice level. So I'm grouping by invoice date, customer ID, and invoice ID, and I'm just adding up all the purchase prices. And I added this other one here, which is stock value, which is just quantity times price. So I'm adding them up. So this is like the total basket amount per invoice an invoice at a customer level. So then, we've done that. And then because the RFM modeling and the frequency modeling and the various Untitled models work on a date basis, I've just aggregated down to the day. So grouping by invoice date and customer ID, and I'm just adding up all the total invoice amounts. And just to put in for interest, I've added up how many transactions there were on a given day. But essentially, if there was multiple transactions on the same day, we're just assuming they're a single, it's a daily spend. So that becomes our daily spend, and that's going to be kind of our invoice. Now, the other thing I were looking at is one of the things they start talking about is that you think of terms of cohorts. So you take and this has all just came from Googling around. So this is kind of, and again, I don't want to my initial idea at the start of this workshop series was to capture that and like live code and, do. Ultimately what happens though is you just end up hanging around for like 10 minutes waiting for me to get something to work. It just didn't really work very well. So instead, I will be doing a bit of live coding and showing stuff later on, because sometimes what happens is, and I want to be able to do that, because what sometimes does happen is you guys come up with good ideas and it's worth trying out. So I kind of include that because, let's have a look and see. That's kind of the point of this. So I've kind of done it, but I do also want to capture that kind of messiness of how is this done? Like, we don't have all the answers at the start. Basically, we use Google a lot, or like GitHub, or various links that we might find, and you read some stuff, and that's kind of how you get a feel for this. So, and I'll be talking about that probably in the second hour. So just from this, it seems that one of the things people look at is you essentially you segment your customer groups into cohorts based on when they first transacted with your business. And that seems to be useful certainly for customer lifetime modeling and stuff like that. So so that was easy done. So I basically created some simple, and you can see we get a whole load of new customers on a daily basis at the very start. And then it just kind of, starts to dwindle off, and then it kind of flatlines around, a certain small number. So then we just kind of created some cohorts based on the date that the customer first had a transaction on the system. And then we put them into cohorts, and I created two separate cohort sets. One was by quarter, which is basically, the year, and then the first 3 months of the year is Q1, second 3 months is Q2, and so on. But also I thought that might be a bit too broad a brush to paint with. So the other idea was just do it by month. So I had basically cohorts by the month of the year. So, slightly finer tuned as a subset of the quarterly ones. And that seems to be important for a bunch of modeling. I don't know if that's true or not, but it's very easy for us to do. So I plugged that in, and we will, we'll look at that, and we're just looking at the new customers by the first transaction date. And then the time difference between transactions, that's also quite important, because you're looking at the standard models we're looking at are called RFM. It means Recency-Frequency-Monetary. So the idea is that customers who are the most recent, i.e., so the way the patterns seem to be in retail is that the customers who have most recently bought with you are more likely to come back. So a given customer is more likely to buy with you if they bought with you recently. So that's the recency aspect. So you want to see how long since their last transaction. That's the recency element. You have a frequency element, which is essentially customers who purchase more often are typically more valuable. So that's the frequency element of it. So a customer who purchases from you 10 times a year is more valuable to you than a customer who buys from you 2 or 3 times a year. And I believe these are broad trends within the industry that I've just got from reading about stuff. There's a whole load of Google it. But also I believe there seems to be a link between recency and frequency. So people who have transacted more recently also tend to transact more frequently. And then finally, the final piece is the monetary amount. So how much do they spend when they do actually buy from you? So that's kind of the monetary piece. So the idea is you break it down into the recency part, the frequency part, and the monetary part. And what we're going to do is kind of look at that in the two different ways, using essentially RFM models, which is a handy RFM package I discovered a couple of weeks ago in Google. And I kind of had heard about it and never looked at it. And I finally looked at it about a month ago and went, oh my God, this is brilliant. It's not complicated. It's really simple, and it's actually kind of useful. So let's have a look at this. And then also my bite of your die models, which kind of take the same approach, but use statistical models rather than simple kind of categorization. The other thing is like the difference between transactions. So what's the, like I just looked at for each given customer, how often did they transact and what was the difference between them? Our unit of time, which I chose completely arbitrary, is in terms of weeks. It just seemed to be most appropriate for the data we were looking at because there did seem to be kind of big gaps between customers. We could just as equally use days if we wanted to, or months. It doesn't really matter. It's just a set of units. I guess it's always nice to have things that aren't in like orders of magnitude higher. It's nice to deal with things on the unit scale roughly, rather than, you know, the subunit scale or, you know, in the hundreds. Let's just normalize things down. Also, there is a computational reason for that. It tends to be when things are at the unit scale, you have less issues with like rounding and various other problems that you might have otherwise. So there's kind of good computational reasons for that too. I was trying to think of various visualizations, and I looked at this here. So I wanted to look at customers here that are, by the way, I'm very conscious not everyone uses R. I hope people can read my code. I'm not going to focus on the code too much, but basically what I'm doing here is I've chosen a bunch of customers that have had at least one transaction. Let me just zoom back out for that. Oops, that's in. Let me just, yeah, so we can look at that there. By the way, is that an okay size? Am I okay like with that? Can you all see that? Just ping it in the chat if it's now small.
Looks good to me anyway.
Okay, cheers. Oh, hey, Des, is that Des?
It is indeed, yeah.
Oh, yeah, I saw admin, so I wasn't sure who that was.
Oh,
hey,
yeah.
So I've made it a bit smaller. So maybe I'll keep it at that magnification then. So basically what I've done here is I've taken a bunch of customers and as long as they have had more than one, because if they're one, it's just a single dot, it's not as interesting. But I think I randomly chose the customers. I'm not sure. I think I did. Yes, I did. So I chose 30 customers. And basically all I did was I drew a vertical line between their first transaction and their last transaction. And then I put a dot whenever they had a date where they transacted. And just to get a visualization of the spread. Another thing I might do, and actually this is something I might look at after, is cohort them by count. So like, let's look at the people who have transacted a lot and look at the people who haven't transacted less often, and just see, is there any good patterns in there? Because what we might find is through a simple visualization like this, we might actually spot a pattern that we wouldn't spot through summary statistics and through numbers. So like I said, the key thing for all of this always is visualizing things. And the thing, I was actually on a call today with some guys, and I was telling them, because I'm all excited about buy till you die models and doing it in Stan and stuff and on a Bayesian approach. And that's going to be kind of a fun one. I think I'm going to start working on over the next few months. But the problem was I ended up with kind of a lot of data and essentially matrices for each customer or for each kind of sample. And I just wasn't sure like how to visualize it. And it's one of the first things I always focus on, very much so, is how am I going to visualize this data? What am I going to do? And this is why ggplot, it's why I love ggplot so much. ggplot is really, really good at letting you do whatever the hell you want to do, like within limits, in terms of visualizing things. And once you kind of get like proficient at ggplot, it becomes very, very easy to do simple things. You might need to manipulate the data just to make it easier to do, but it allows you to create some really, really useful plots to kind of solve the visualization problem. So you can kind of see here, like this guy here, 14680, he's just this, well, he or she, I'm saying they, let's use the gender neutral pronouns. So they have, you know, loads of transactions here in 2010 for the first 6 months, and then it kind of drops off a bit. But it's pretty uniform the whole way through. Whereas this customer here seems to have some bursts around Christmas by the looks of things, coming up to Christmas again. Yeah, so this might be like a seasonal purchaser, although we were very regular at the start of the year. You know, this one here is almost like clockwork. So it's just very and to be honest, I'm only looking at 30. I should probably do this for a lot more, but I think it would be interesting, and I'm thinking of this in the fly now. I'm always going back. By the way, originally I had this as part of my modeling, but I put it in here because it's nice to have everything in a single place. And again, that's the other thing to point out, like these things are evolving over time. Don't be afraid at any point to just kind of throw everything out and start again and essentially copy and paste and refactor things, because the old joke is at a very minimum, you're always working for two people. You're working for you and you're working for future you. So that's why I use a lot of visualization. It's why I use R Markdown or Jupyter Notebooks if Python's your thing, because it allows you to put your code and your visualization and your thought process in a single place. And if something is confusing or you're not quite sure what you're doing, write it down, put a couple of sentences in, because if you're having this trouble now, if you come back to it, you probably will have this trouble again. And what I have found is when you start doing this kind of work, you will often come back to work you've done before. So it's always handy to pay attention to future you. And that's why I like working. So now, if I was putting this stuff into production, to go back to like the talk we had in June with Fiona, that's a very different that's a very different thing. Patrick, I've just seen you have a question there. I'll look at it in a sec. You know, so paying attention to where you're going to be in the future is very good, and having it all laid out with some visualizations, explaining your reasoning, explaining any issues. If there was something weird you had to do as a budge, putting it in there in our Markdown and code, source code control, and all the other stuff I've talked about, you've heard me go on about ad nauseum with Docker and stuff and make files, all of that. Like, it's all about, it's not so much about being some kind of like academic purity or whatever. It's just about practical usefulness and helping yourself in the long run. Just one sec. So Patrick, is there any commonality in the products people buy before they drop off? Are they completing sets or hitting a disappointment, even if they don't complain? Oh, okay. Products that are refund. You know what, Patrick, those are all excellent questions that I do not have the answer to, but I will have next month. So that's a really good question that I haven't thought of. Now, the one thing you do have though, so this is one of the things that comes up in both these models, is this is what's called a non-contractual setting. So you have customers that are not obligated to pay you money on a regular basis. So think like contractual basis would be things like a phone company or insurance products, or, you know, broadband or utility bills. Those are all, you're essentially contractually obligated to pay you money every month. So it's much easier to discover churn in those situations, or like, and I don't want to say it's easier to do lifetime value or anything like that, but it's a very different problem in those settings, because you generally have a better handle on a customer who has churned or not, because you'll see that they're no longer paying you money on a regular basis. Now, there is a question of, if they stop paying you money on a regular basis, at what point do they actually churn? Is it just that they didn't bother, or something came up, or whatever happened? I mean, that can be hard to tell. But for this case, when it's a contractual basis or non-contractual basis, is it just that the customer like is planning on buying in the future and just hasn't bothered, or is it that they're no longer a customer? And it can be very hard to tell. And the buy till you die models, which I will probably get a little bit of time to discuss at the end of this session, handles that, because there's that trade-off between the two. Like, is the customer still alive on the system, or are they just a low frequency purchaser? But that, combining that, is something I'm thinking about for the next one, Patrick. And so the first question is, how do we know if they've dropped off? That's something we're probably going to have to look at. The idea of completing sets and looking at, yeah, the one thing I haven't looked at yet is looking at, well, we did it a bit with the basket analysis in terms of what customers are buying by themselves. But yeah, that is an excellent question, that hitting a disappointing product which puts them off future purchase. Yeah, the products that are refunded more often. So that's a very product-centric approach, which I kind of addressed with the association rules, which we did in the third workshop, I think it was. I touched on them briefly in the second. So that was essentially basket analysis. Actually, let me bring that up, because it is important and it's kind of came up. Oh, wait, no. Do I have it here? Oh, I do, because this is a previous rendering of it, because there's one piece of code in there that takes ages to run, and I don't have it cached.
That reminds me of when I was doing the car rental website. I know that was something was discussed. We never went anywhere with it, but it was discussed because some car rental companies have a very bad reputation. So you're thinking, right, could you actually quantify how, like, was it worth maybe giving up a sale by just not selling these ones? Like, were they so bad that they just weren't worth dealing with?
Yeah.
And there was one, but don't casually, and it was one of those throwaway comments where we went, oh, we really should do something, but then we never did anything with it.
Yeah, I do know of a life insurance company in Ireland that basically took some of our work. We were doing some lapse modeling, and they took some of the work. Now that was this is very much in a contractual setting rather than non-contractual. But what they did notice was it's a bit like that. It wasn't that the customers themselves were no good, but the brokers, which is one of their distribution channels, they used it as part of a broker analysis to try and figure out basically which brokers were worth dealing with and which ones weren't. Because some brokers were very, very good at gaming your commission system. So like back in it's a bit like, if you can think of it, I don't know if any of you have heard the stories with like in the Bahamas and stuff, there is a lot of competition for mobile phone customers, and they made a lot of money off the pay-as-you-go bills. So what they would do is, if you were a customer pay-as-you-go and you hadn't topped up in the last 3 months, they would give you free credit to come back. So what people would do is they would have like 3 or 4 SIM cards, and they would basically not use a network for like 3 months. And then the network would send them 20 quid or $20, whatever it was. And they go, sweet, and they get the free credit. And then they churn. So they were basically on rotation. And their systems were so bad, they were just blindly sending out this credit every few months to people and not realizing that essentially the people had figured out that they were gaming that system. And that's what brokers were doing. And exactly like that, they actually found there was a whole bunch of people whose business they just decided they didn't want, because while they were giving up revenue, they were actually also giving up loss making. So yes, it affected the top line negatively, but it affected the bottom line positively, because the broker would churn and then they'd keep their commission and all that kind of stuff. The usual kind of shenanigans that you can think people would get out. Now, I'm conscious I didn't talk about association rules, but on that point to what you just said and Neil said, and Patrick said, basically, like, this is a big mess. I appreciate it. So let me see if I can just zoom in on this a bit, maybe. No, hold on. That might be an image. There was one. There we go. That's the network graph. So there's a network here. So what you're doing here is you've got association rules where basically when items co-occur in a basket, and what we're doing is looking at the likelihood of customers to co-occur in baskets and essentially create association rules based on that, and then get commonality of items. So that would tie into like what you were talking about, Patrick. So I think, and this is kind of where I'm going with the other modeling, is to basically start looking at a combination of items that tend to co-occur and customers, and how is there like, can we associate these clusters of products with the different categories of customers? And that might give us kind of a more holistic view, because you're kind of combining the two. And typically when you combine different perspectives, you get a much more sorry, Yash, do you mind just going on mute? There's a bit of background noise from you there. Yeah, perfect. Thank you very much. Sorry about that. Perfect. Or do you have a question? Yeah, sorry. Did you mute to ask a question? Did you unmute to ask?
No. Sorry, it was by mistake.
Oh,
sorry.
No problem. No problem. Just because you probably didn't realize. Okay. So
Sorry,
yeah.
I actually have a question. It's going
Sure.
back a while, back to when you spoke about the issue of trying to work out how to visualize those matrices.
Yep.
So it's partly a comment and partly a question, because I often use the R graph gallery, which is a subset of data2viz.com or something.
Okay. Let's Google it right now. This is what we're here.
Yeah, have a look at it, because my question, that's my comment. My question was, how do you try and find what to use? Because I find that particular website's brilliant for deciding on a graph, because basically it looks at what variables you have, and it'll be like, right, you've got 2 categorical variables and 1 numeric. Do this plot or this. Yeah.
The short answer is I don't, Des, because I haven't needed to so far.
Yeah.
But that's probably arrogance on my behalf. I didn't know about that. I'll probably take a look at it either in the break or certainly between now and the next workshop, and let you know.
I highly recommend it. And then it gives you links then for each of them to either R, Python, or D3.
Excellent. Okay. Yeah. Would you mind putting that link in the chat?
I will. Yeah.
In the
I'll do that now.
in the Zoom chat, if you don't mind.
Great.
And I'll take a look at it. The short answer of it, this is where it's that tired cliche of it's an art, it's not a science, and visualization is very much that case. A lot of it comes from experience. Now, I do not have an artistic bone in my body. I am just terrible. I'm no good at aesthetics or like I tend to be quite minimalist in terms of, but that's the great thing. ggplot lets me create like graphs that look decent, but I also tend to go very simple. And sometimes obviously that Dublin data art. Okay. Yeah, and if you wouldn't mind Des putting that in as well. But to answer your original question, like what am I going to do with those matrices of data? I am going to answer that next month once I've had probably, or in the next few months, once I've kind of had a chance to look through it and figure it out, because I don't know the answer to it just yet. I kind of have my suspicions, but about things that might be useful. And it might be just a question of, you know, it's just too big and I'll just sample it and I'll do some visualizations of the samples, kind of like what I did here with this retail models and just this kind of stuff on a larger basis, like just take a sample of 30 customers and plot some data based on them. Now, with the Bayesian code, excellent. With Bayesian code, it's a bit more complicated because you're dealing with posterior samples, so there's just more data to visualize. But yeah, so we're, you know, and we're looking at the cohorts here. And what time is it? Oh shit, it's 8 o'clock. Yeah, so you know, we're now, we did take a product approach before. What we're kind of taking now is a customer approach. So we're going to look at different customers, how they work, and like where they go. And I'm very conscious that, you know, I've been talking for an hour now and haven't really, well, not an hour, but let's say 45 minutes or certainly 40 minutes without really discussing anything new beyond some nice new visualizations. So yeah, you know, I just taken a look at these different cohorts because, like I said, from a customer point of view, there seems to be a trend, or it seems to be kind of one of those received wisdom, or whatever that's worth, that customers at different, who join at different times in the, not necessarily the month, but literally like the combination of the month and the year, or the different, a period of time, will behave quite differently. So typically that's a partition of the data that a lot of these models take. Now, I'm always a bit, I mean, from the point of view of one, like the secret weapon and stuff, which I might get to talk to about a little bit later, which is a Gelman technique that a guy called Andrew Gelman talks about it. It's great because it gives you a very natural way to you know, disjoint, like create disjoint partitions of the data, and you can fit models on separately. But at the same time, it also makes the assumption that they behave very differently. And what I would like to do is kind of blend the two. So come up with essentially hierarchical models. Now, all of that is beyond the scope of this workshop, unfortunately, because it involves going down the Bayesian route. I want to understand the stats properly. It's a very interesting topic in and of itself to really do that in a kind of a rigorously statistical way, which I think there is a lot of value of, but I also don't want to, like, it's eyes on the target. The idea here is to do a data science problem from start to finish. And I think I can already do quite an interesting project without going the fancy stats route for the purposes of this. Now, I find it such an interesting model. Like I said, it's going to be basically the focus of an entire workshop series that we're going to do later. So what I'll probably do today, and we're going to take a break now because I notice it's 8 o'clock. I'll take a break now in a minute or two. We are going to talk about these RFM models, which is essentially that recency frequency. There's a package called RFM in R. There's probably one in Python. I don't know. It's a very, very simple idea. But essentially what you do is, rather than do any kind of fancy modeling, you basically look at the time from the most recent purchase, which is the recency, the frequency, like how many transactions were made, and the amount spent. And you basically cut them up into quantiles. And then you look at the different quantiles and you define some combinations of those three values, and those become your customer categories. And yeah, so basically it's a very, very simple idea, which I love. For those of you who know me well will know simple is really good, because if simple is effective, then great. And at this point, you know, if you're coming in, I'm coming in blind onto this, I'm going to start very simple, especially if it means I can explain it very easily to people. Like, I don't have to explain a whole load of stats to make them, or even hand wave too much. I can basically say, here's what they're doing, so that they can understand, and they kind of think, I could have done this myself, which can be both good and bad. And then we're going to do some basic stuff on that. Yeah, sorry, Patrick. Yeah, that's always the way it works. Yeah, by all means, Patrick, give me a shout some other time. I'm happy to have a chat one of the days if we want to have a chat on the phone or whatever. just give me a shout. I'm conscious you always have to leave a bit early. But yeah, you can catch it on YouTube later on. All right, so look, that is a good place to take a break. Before we do that though, and I'll turn off my camera just to let you know, does anyone have any questions before we go? Now, I kind of talked at you a lot. I know there was a bit of back and forth there, but does anyone have any questions for the next, just before we take a break for say 5 minutes, or while we'll take a break now from everyone, but does anyone have any questions? No. Okay. All right. So I think the best thing to do is I'm going to take a very quick break, and we'll come back at say 5 past. I'll ask a bunch of questions. You know, if anyone has any questions or comments or things they want to check out, I might even do a quick Google on that website and those things that Patrick linked. And we'll start back at 10 past. But I'll be back here in about 2 or 3 minutes. Okay. So let me just put myself on mute, and I will turn off my camera so that you'll know when I'm gone. Hold on a sec. I know this is fascinating stuff. I'll be caught for got it, and then put myself on mute. All right, I'm back. Turn on the screen, start the video again. There we go. And yeah. All right. Let's have a quick. I'm back. If anyone has any questions or wants to ask anything, now is the time to do it, by the way. Before I start back, I'll start back in a couple of minutes, but let's have a look at this data to viz that Des suggested. Data to viz. Okay. Oh, okay. Yeah. Yeah, some of these I don't use enough. Like I use box plots and histograms, obviously. Density plots I used to use an awful lot of. I've kind of switched back to using histograms. I don't know why that is. I think what happens with the density plots is when you're using a density plot with real data, because of the kernel estimators, it essentially puts little parabolas on every data point and then adds them all up. So what happens is if you get these outliers, you get these density plots where you get this completely flat, essentially zero probability density, and then you get these bumps. And that's always just bugged me. Like it's no different from a histogram. It's, you know, a continuous version of a histogram, but it's always pissed me off, and I don't know why. I realize, you know, the fact that it doesn't get bumped up a bit and attenuate away has always just kind of bothered me. So that's probably why. But yeah,
do you use violin plots at all?
I know that's what I was going to say, and I should use them more.
Yeah, they're great. They're great for polymodal data.
Okay.
So I mean, you don't want too many groups, but like if you've got like 2 or 3 modes.
So it's, if I'm right, a violin, just because again it's been a while, so they're like a box plot, but rather than a box, it creates essentially a.
You know, they're actually density plots mirrored against it in the middle, down the center.
Yeah, that's what. Yeah, so it's essentially a vertical density plot.
Essentially, yeah.
Right. Yeah.
So they're very good for certain distributions. Yeah.
They might actually be useful for some of this then, because certainly by the cohorts, just thinking about it there, like if you've got, like, let's say we categorize our customer base, and then we do violin plots of, say, the spend or the frequency or the transaction count by group, that could be quite useful. Okay.
Yeah. And they work with, once your groups are kind of like less than a dozen, you can what do they go? Faceting is great for them.
Right. Okay. Yeah. Okay. I'll definitely give that. I'll give that a shot then. I'll see. Yeah. See here, it says here a histogram rather than a density plot, but yeah, I mean, I deal with now. I guess it might be less problematic, because nowadays what I do often do is do a log scale, because I do tend to deal with skewed data. So when you go onto the log scale, that does kind of compress that down a bit. So that certainly makes things a bit easier. Yeah, I like that. Thank you, Des. That's
it's
very, very
great.
useful.
And then if you just just go up one to the top there, and then you'll see there's sections on networks, and then combinations of numeric and category. Sorry, you know,
So, and
then you can get, you know, what's best when you're combining them and so on.
Yes. Okay. Excellent.
So yeah, it's great.
Yeah,
and then
thank you.
Whenever you click on anything, then it'll give you the option. Then have a look at the R graph gallery. I mean, you'll be familiar obviously with all the code, but most of it you'll find.
Very good. Yeah.
It'll then and it'll give you like the most basic version of everything, and then it'll start.
Then the R graph gallery
helping you. You know.
No, that can't be right.
Couldn't be.
Hold on, let's just have a quick scooch.
I used that a lot really when I was first coding, and you know, because like you obviously haven't got like ggplot's pretty, when you're new to coding, like ggplot was quite difficult to get the, you know, I didn't understand basic things like the fact that putting your data into a particular shape before you plot it, you know, that took quite a while to conceptualize.
Oh, there we go. Okay, that's all right. Cool. Base R, I don't know why you would, but okay.
There's a couple of violin and base R. There's a couple of things now that he'll talk about there that do go well in base R.
Right. Okay. Yeah, I just don't use base R for anything these days unless I absolutely have to, because
no, I hear you.
Speed. Well, it's definitely much faster. There is a, like, the tidyverse does come with quite a serious speed up. Like it's definitely a lot slower than doing indexing. But the conceptual loading is just too high. I'd much rather understand my code and throw a bigger machine at it. That's just
and also the fact that it's like it's consistent, because you'll do one plot in base R and it'll have certain set of graphical parameters, and then you'll go to the next one and you can't remember what's what. It's a nightmare.
It was the main reason why I never really warmed to pandas, and this is before the tidyverse came around. It was just because it was using matplotlib and stuff like that, and I used matplot back in the day, and I just hated it, and I just was like, no, I need my ggplot. And there's been a couple of attempts to bring it into Python, but I don't think any of them have been particularly successful. I know matplotlib, there is 2 versions of matplotlib, apparently. There's 2 APIs, and I know it's very good. I just never got my head around it, and I don't need it. So
I actually discovered a Kaggle. I got an email from there the other day. There's a 30-day machine learning course, so I think you do a bit every day, and it's for people who have little or no Pythons, because it's all done through Python. So it's a great chance for me, who's like really
just a good way to learn Python.
It's a good way to learn it.
Don't use it for the stats, but use it for the Python.
Exactly.
I really don't like the use of Kaggle for learning machine learning, because I think it gives you it goes back to that point I made at the start, where I think it gives you a very unrealistic idea of what machine learning and these kind of projects are about, because it kind of gives you the data in a prepared format, and it gives you the loss function, and you just have to come up with the best predictive model.
Yeah.
I think that, and I know they've moved on from that in some projects, but I just don't find that particularly interesting because it just becomes about an engineering problem of engineering the best kind of machine learning things.
Yeah.
And using your deep learning and all that kind of stuff. And I just don't find that interesting.
Yeah.
I find the hard, it's not hard. You can give that to a junior these days. For the purposes of real life, solving real life problems, obviously no way a junior person will win Kaggle competitions, but you can do quite well with just like running libraries. And that becomes kind of the hard part is figuring out what to do and how to measure it and what becomes your benchmark and how do you know one model is better than the other and all that kind of stuff.
Yeah.
You know, that's where the hard part is. But okay, all right. So it's 10 past, so we'll start back. Does anyone else have any questions before we get back into it? Oh, hi James. Sorry, I thought I discussed that. That it's from the UCI machine learning. Hold on, I'll bring that up just before we start back. It's the UCI machine learning repository, I think it's called. It's the online retail 2 data set. So there was one before this, which I think was from a few years before that. I think it's from like some UK-based online web storefront for like artisan type household items. So it's from here and it's online. Let me just bring it up here. So I wanted to get one of these, and there was an online retail 1, which some people had used in the past. Let me just see here. Is it retail? Oh, so it's gone missing. Yeah, it should be on here. Hold on, you've kind of stopped unless it's been taken down, but I don't think so. Hold on, let me just check. Archived online retail data set. Ah, there we go. It's that. It's number 2. All right, let's go back. Yeah, it's this one here. Like I said, the downside to this is just how sparse the data is. It's you know, basically this, and there's some things in these various academic papers that I don't think even discuss the data. I should actually, I keep meaning to, what I haven't done, there was some data around this which I read. There is, you know, it's all this here, some retails, there's very little data on it, and there's no real explanation of the context. So, but it's an online retail data set that's freely available and we can use. So, and it's a way of learning this stuff, which is, I would definitely say I have succeeded from my own point of view of, I now have a better sense of how these things work. We have a question here. Please explain Bytely die versus RFM differences. I will get to that. That's going to be the top. I'll talk about RFM now. That's what I'm going to start on. And there are essentially 2 ways of approaching the similar kind of concept. Robert, let me talk about RFM now, and we'll probably have a little bit of time to at least give you a taste for Bytely die, and I can kind of explain it. But effectively, if you want to put it in really simple terms, Bytely die takes a statistical modeling approach, so it actually fits probability distributions and it has optimization routines and stuff, whereas RFM is much more effectively unsupervised, sort of. You'll see it here now. You essentially split the data up. You calculate various metrics. You split them up into quantiles, like 5 quantiles, I think is the standard. So you have, you know, highest 1, 2, 3, 4, 5 into 5 buckets. And you do that for the 3 metrics. And then you just basically, depending on which bucket a customer falls into, you then have a bunch of categories based on the combinations of values. So it's very, very simple. It's basically done through lookups. It's not really what you would call statistically based at all. Whereas Bytely die is like hardcore probability distributions and fitting the models and stuff. Does that kind of make sense?
Yeah, that's perfect. Yeah, nice.
Yeah, no problem. Great. Hopefully it'll make a bit more sense by the end of the hour. All right, so let's look at so like I said, we have talked, and I've talked ad nauseum about kind of what we were doing. Let's talk about some new stuff. Because I wanted to, you know, context is important. Sorry, we're going through all of this here. But now we're going, so this came along and it was something I found I don't know how I came across it. There's a package in R called RFM, and I never looked at it. I actually had it in the original Docker build. I've always known it was there, and I never really looked at it. I'd spent a while going down the buy till you die kind of road, and then I came across this, and I went, I love this. This is just so simple. It's really easy to do, and it comes in the RFM package. So let me actually, similar to what we did with the A rules package, if I go, which is association rules, if we just go RFM, there's a really nice vignette that comes with the package that just kind of explains what it does. Let me just bring, now, there's two vignettes here, customer level data and transaction level data. And as far as I can tell, they're almost identical. I'm not quite sure what the difference between them is. The contents of the two of them are almost exactly the same with slightly different function calls or something. So that might be an oversight or something. I'm not entirely sure what that is, but just be aware of that. But basically it comes with a nice kind of vignette that talks about taking data and creating some plots. So basically what I wanted to do was look at take the data in and just play around with the package and see what it would tell us. So like I said, in all of the things that we've done so far, we haven't really had any strong idea of what the output is going to look like. And that is still the case for this work, for what we're doing today. All we're really doing here is we're building what I call exploratory modeling. So we're not necessarily building models to make predictions or to like as a final model. What we're kind of doing is just looking at, it says here my internet connection is unstable, by the way, so hopefully that came across okay. We're building models to understand more about what we could possibly do, or to maybe learn a bit more about the data set, or to potentially identify any problems with the data set. Because if you run a model and it blows up or gives you weird answers, it's probably that the data is doing something weird and maybe you need to clean it a bit better. So it's all part of that whole kind of process. So in this, I literally just loaded it up and just tried a bunch of things out from the RFM. So like I said, we've got some daily spends. We've got like customer RFM data, which is this RFM table order, which is internal to the package. So don't worry about that, but it basically boils it down into essentially the data of the most recent transaction. So on a per customer basis, it calculates some statistics. So there's a customer ID, the date of the most recent transaction, how many days, the recency days, which is how many days since the last one, the transaction count, the total amount of transactions for that customer, how much they spent. So you can see that's a very high one. And then it sticks them into these 5 different categories: recency score, frequency score, monetary score, and then the overall RFM score. And that creates it in the relevant data structure. So it outputs here as a tibble, but it's not actually a tibble. It's like an object. When you do the print function on it, it prints the tibble. And now we can do some visualizations. So we can look at the RFM data, just a heat map. So it's a heat map of the frequency buckets and the recency buckets, and then the mean monetary value within each bucket. So what this is doing is it's saying, okay, so the frequency was the lowest frequency and the lowest recency, as in the furthest away and the least frequent customers, and how much have they spent on average. Whereas up here, we've got a whole lot. Now, I am a little bit suspicious about this data here. We might need to clean it a bit better, because if you look here, like the most frequent customers and the most recent customers have spent a lot of money. But I'm worried that maybe because we're calculating a mean monetary value, and I'm just looking at the default output, I wouldn't use this. So like I won't put commas there, and I probably would make that a bit smaller. And there's formatting issues I would want to change here. But you can kind of see here that definitely your most frequent customers tend to spend the most money. And interestingly enough, though, the least recent but most frequent customers seem to spend more than these intermediate ones. So that's something to look at. Again, looking at it here, maybe we need to clean the data a bit better. And again, like I said, I very deliberately not done this with as much polish as I probably would have if I was presenting this as a talk, because I want to show that kind of dirty nature of this, where you do things and things don't look right and you think, oh, probably need to fix that because this doesn't look right. So like immediately, maybe the fact that I haven't included the returns means maybe we've got these large ones that were actually a fat finger or something, and maybe we need to clean that out. So I'm going to look at that. I might look at maybe my exclusions aren't quite as good enough as they should be, but that's okay. That's to be expected. So all I'm looking at
five quantiles already, or did I miss the
five quantiles? Yeah.
Yeah. All right, that's great.
Just use pentiles or something to be
Quintiles.
arsy about it. Yeah. So there's and that's the default. I think you can set it in this function here, RFM table order. So you're giving just the names of the relevant columns in the data and then the analysis date. So this is up to whatever date we set it for, which was the 31st of March 2011. So we've left about 9 months at the end of the data as like our out of sample, so that we can use to do some kind of data validation on what we're doing rather than using the whole data set. So you like your standard idea of holdout. So yeah, it's very simple, and it basically just cuts things up into quantiles, into 5 buckets based on the various data. And hi, Caleb, would you mind just put yourself on mute? There's a bit of background noise there. Thank you very much. If you have a question, by the way, feel free to jump it up. I didn't want to let you know. I know some people join and they're not muted by default, so I just wanted. But if you have any questions or you have any comments, feel free to add them in the chat or just unmute and shout out. So yeah, so there's a bunch of things. This RFM bar chart. So what it does is it divides it up into frequency and recency, and then we do a bar chart of the monetary score. So it's just doing count bar chart plots. So again, we can see that, you know, in the various categories, there's a lot of people in there's a big count of people with high frequency and high recency. They're also mostly in the high monetary count. So that's kind of it. So these things seem to be kind of positively correlated. If you have a high score in one, so just to be clear about this, recency is how long since your last transaction. So a better recency score is a lower number, because a more recent transaction is better than a more distant transaction. So that's the one that's kind of the opposite of what you would think. So a lower number in recency is better than a higher number in terms of time since last transaction. And then the frequency score is obviously just the count of transactions that have been made, just pure counts. And then this final one is this recency monetary, which is just putting the amount spent into buckets and looking at it that way. So we can kind of see, and also when you have a low recency and a low frequency, you tend to have spent less as well. So again, we're kind of seeing that the conventional wisdom here of like low values in recency and frequency correspond to low values in spending. Okay, in the middle here, it's a bit of a you know, a mixed bag, but certainly low frequency and low recency is combined with low spending, versus high frequency and high recency is correlated with high spending. Okay, so there's a whole bunch of these that they get there, and I just thought, oh, this would be interesting to look at. So I basically just plotted them all out. We can see some interesting gaps here. So the reason for this gap here, and I kind of looked at, and this is always worth, these weird artifacts are worth looking at. And the reason there's a gap here is, if you look, the date we set was the end of March, which is about 100 days from the Christmas break. And then this is the other gap up here. So if you remember, there was no transactions whatsoever for those 12 days. So I think that's why we're seeing those gaps on the recency, because there was no one transacted on those days at all, whereas a lot of other customers did. And if I'm looking at this properly, I'd probably do some, these are ggplot output objects. So I'd probably put like a log scale on this, because that's not really telling us as much. But I wanted to kind of see how it looks. So now we've done a plot of frequency versus monetary. So the frequency is how many transactions have been made versus how much was spent. So we're just looking at all these different plots. Okay.
Sorry, Mick.
Yes.
How is frequency measured? How many transactions, like, per what?
Frequency. No, frequency is literally total number of transactions.
Oh, sorry. Yeah, great.
It's not a rate. It's how many transactions did the customer.
It's a count.
It's a pure count. And then obviously bucket it up into 5 buckets.
Yeah, cool.
Yeah, simple as that. So it's the thing I really like about this is just how simple. Like, it doesn't really matter how technical, how non-technical a person is. You can explain this approach to anyone, as long as you're, you know, you can speak in coherent sentences and can explain yourself. But it's a very, very simple like non-fancy approach, which to me is already, I can tell, is kind of effective, which I love. I mean, anyone who knows me, the simpler I can do something that's effective, I don't go for fancy models if I don't have to build them, because that's just asking for a whole load of herb. It's very hard to fuck this up. Like, it's a couple of lines. You could write it yourself if you had to. If this package went away, I could write this code myself, and it would be a lot less likely to fuck it up than like if I was building a fancy statistical model. And now I've sworn, so I finally got the explicit tag. God damn it, on YouTube. Never mind. Oh well. Okay, I was trying very hard not to swear, and I did so well in the first hour. Never mind. All right. Okay, so then we've basically created all these categories. So up here you can look at. Actually, let's run this data. Let's show. I think I've run this in the background while I'm talking. So render initial Rfm levels. So we can have it here in the background. Oh, there we go. Sorry. So I'll have some code here in the background so we can look at this in a second. It's always nice to have, you know, like stuff in the ready to roll, so that we can actually, you know, do some stuff with it. And maybe I'll look at, there's a couple of them I want to look at. Like, I really don't like this one at all, because first of all, look at that, that's terribly labeled. And secondly, a monetary by default should at least have commas in it, even if you don't have dollars. Because you know, not every euro, not every currency is the dollar. Despite a lot of people who write these packages would have you believe. But I just don't like, it's so skewed. I think we'll learn an awful lot more by putting this on a log scale. So that might be something we'll try. But let me see, did that run? I'm sorry, I'm just clicking. Yeah, there we go. So, and the other great thing is it's really fast. Like, it doesn't take long to run at all. So yeah, so if I run the recency model, so I have, let me just see here, we have, just copy and paste this. So where was it? I was here. So it's Rfm plot. So we're going to generate that plot. We have it there. So let's add like a log scale. And what was it I said I was going to look at? I've completely forgotten. I'm so busy talking over myself. Labels equals label. Is it format comma? I think it is. Library scales. Is it label comma? Maybe it's label comma. I never remember which is. Oh, God damn it. Okay. There we go. So now we've put it up onto like a log scale, and we've added a bit of. This is something I would probably be more likely to add in. So we've got the recency and the frequency. So we have, again, we have that gap around the Christmas times. But yeah, we can see, you know, most of the transactions are between $100, 100 probably British pounds, and £10,000. Although there is, you know, there is chunkier transactions up here. Although that would tie in, like we said, there's wholesalers here. I missed that. I've actually missed that there's wholesalers in that. I've only just twigged on that now. So that might explain some of these larger transactions up here. So one of the things I'm going to go back and look at, I think, between now and the next workshop, when we finally decide what we're going to do, is to just see, can we identify wholesalers, or is there some commonality? I think we looked at this before and didn't find anything. But anyway, just to say. So yeah, you can see there is, you know, there's not that much of a relationship though. Well, I suppose there's a bit, because it's on a log scale though, right? So you can see this slight decline going from, you know, more frequent, more recent stuff is kind of declining down. So, you know, there's a big chunk between 10,000 and 1,000 and 1,000 here, whereas there's very little when we go back to the more older stuff. Although then again, maybe there was just less business. You can see there was actually a lot of transactions done kind of in the previous kind of between 100 and 200 days ago. There's a lot of dots in there, so that's kind of interesting too. I might actually mess around with these plots a bit more and kind of, you know, see, is there anything else to be done, because we are losing a bit of noise there. Maybe add alpha, or make the dots a bit smaller or something, or I don't know, maybe add some colors based on the country. There's a few different ideas maybe we could do there. And again, this goes to the point I was making earlier about trying to figure out, you know, how do we look at that? Can anyone remember what I said I was going to look at, by the way? Can anyone tell me that? I was going to look at frequency and monetary. Yeah, well, let's do this one too, with a log plot. So and add that in. So, and if anyone else sees anything they think is interesting and would like to look at, please shout out. This is the forum for it. So we have, this is the frequency versus monetary. So you can see here, yeah, there's a lot of small numbers of transactions, and then it kind of explodes out here. Still isn't the most useful. Let's add a log plot to the y-axis as well. Scale y.
You know, I was just checking there. That doesn't seem to have a weighting option on it that you could weight by monetary value, which I've found with as an alternative to the log scale with histograms or whatever, so that you put more weight on the higher monetary values.
Right. Okay.
Yeah.
Well,
So
what you could do is set the size of the point or the color of the point by the monetary amount.
That might.
Oh no, but you've got that there actually. This is monetary and frequency. So yeah, it's interesting to see just how the log scale works with all of this. But yeah, so we have a reasonably smaller amount of larger transactions. And then some of the really big ones are being done by, now this is the total spend. So it kind of makes sense from a monetary point of view that the more you transact, the more you spend. Like they're not looking at, I don't think the monetary bucket is done by total spend rather than average spend, which is both good and bad. You know, I can see the arguments for doing it both, but it does mean that you're going to very naturally get a relationship between frequency and monetary, because, you know, the more people transact, the more likely their total spend is to be higher.
Yeah.
But not necessarily. As we can see, you're still seeing some people down there with one transaction who have spent 10 grand, you know, which is still more than most people have spent, even though that some of them have a lot more transactions. So that in itself is interesting. You don't remember what I was talking about, Neil, do you? I was going to specifically.
No.
But I've now completely forgotten.
Sorry.
Oh, it was the different cat. Yeah, that was it. Sorry, we're actually going to look at the data itself. Sorry. So
Robert has a question as well.
Oh, shoot. Is there one command that can be used to run off and return all findings? No, is the short, as far as I can tell, no. However, it's very, very easy, and this workshop is well on the way to just creating a package like an R markdown that does that for you. And then you like, it's kind of what my data expects is. So this exploring one here, most of this is pre-coded. The first 5 sections are essentially a template. That's the other great use of R Markdown. You can kind of create these like templated things that let you do that. In terms of return all findings, they won't do the findings for you though. They're not going to come up with the answers. All they really do is generate all the plots for you. And then you've got to go and do the actual kind of hard work of figuring out what happens, because, you know, there's nothing that's going to do the job of finding all the answers for you, because a computer isn't that smart in terms of, you know, getting the answers. Is that kind of where you were going with that, Robert? Or were you thinking more in terms of just creating all these plots?
Yeah, initially creating all the plots, I suppose. But yeah, like, no, I think you've answered it very well there. Yeah, that's perfect. Thanks.
So yeah, I mean, and that's one thing I probably would do, is just create a workbook, because basically all this package is a whole bunch of plots and one handy routine that lets you do the segmentation. But it's more than useful to just, I mean, there's only 10 or 15 of them. It makes total sense to me to just run them all off in a single worksheet, and then you're done, especially if this is something you do. In fact, that's probably what I will have done for the next one, because the modeling part of this is probably going to be like a keystone. The way I'm kind of going on this, as you can probably tell, is I'm thinking in terms of these RFM kind of categorizations, because they're very, very simple and they're easy to understand, and they seem to have a certain amount of, they seem to be quite useful just from looking at them, that we're going to look at in a couple of minutes. And then the other thing is combining that with the association rules outputs, and we have like these categories of products. So what I'd like to do is essentially combine the two together and do some outputs that we can show, and that will be our findings. Maybe we'll build a Shiny app too, which I mean, I don't really want to go into Shiny too much, and I certainly won't go into the code of it, but what I might do, depending on how it goes, and that will depend a lot on the context of the next workshop, we might actually just create a quick kind of Shiny tool that we could then potentially put on a web server and give to someone so that they can play around with shit. And that to me has been very, very handy in the past, because you're not just giving them reams and reams of packages, you're giving them a little app that they can play with and get interactive on, and basically sliders that they can move around and stuff like that. In my experience, that goes an awful long way to provide to getting buy-in. Okay, so we have where are we? Here we go. So all right, so we have all these. Oh yeah, that was it. So in the RFM data itself, customer RFM data, you can see so that's the printout. When I do a glimpse on it though, I actually look at the structure itself. Oh, what the hell? All right, let's go str then. Look at the structure. You can see it's a class. It's got a bunch of stuff. When we print it out, we're looking at one of these, but essentially we've just added these RFM scores as well. So there's a monetary score, and then there's this thing called the RFM score, which is basically just what bucket were you in for recency, what bucket for frequency, and what bucket for monetary. So we can actually look at that. If I go RFM and then $RFM, and then select customer ID, comma RFM score. That's FRM, RFM. Select. We now essentially have a score for every customer. So we've basically created this bucketing value for every customer in our database. We have 4,700 customers in the database. They all get an RFM score. Okay. So what does that do? Right. So what we can do then is what RFM gives you is you basically create these packages, and I didn't have any basis for that, so I just went with the defaults. So if you look at this code here, basically what you do is you look at a bunch of categories and you basically say, hold on, where are we? Down here. Let's look at the categories. So you basically say, all right, let's create a segment where our champions are basically customers who have a 4 or 5 in recency, frequency, and monetary, right? Our loyal customers are, recency of not 1, and then a frequency of 3 to 5, and a monetary value of 3 to 5. So, good values, but not necessarily always the most recent. And then these here, potential loyalists, 3 to 5. And these came with the package, so I just went with them. But you can see here, basically, now, the one thing I did want to check is what might happen is you will have customers who apply to multiple packages, to multiple segments. I think the way it works is, and I can't guarantee this, is it basically goes from the top down. So once it goes to a customer and it finds a bucket to put them in, it stops and it doesn't find it. And then I think there's an 11th category, which is other, which doesn't match to any of them. And then we have a little package in here that basically does all the values for us. And yeah, I was looking at missing customer segments, and we just apply them. So we do this RFM segment. You put in the segment name, the recency, the recency lower and upper, the frequency lower and upper, the monetary lower and upper, and you do it like this. And then you basically apply each customer to it. And then we have essentially a category for each of our customers. So each of our customer, we have the customer segments, and we're going to look at basically the data based on the segments. So the about to sleep, there's 323 of them. There's 313 at risk. There's about 1,000 champions. There's about 1,000 loyal customers, about 600 lost, 200 need attention, 270 others, and about 1,000 potential loyalists. So automatically, we can actually start to get a sense of, how this works. So we're going to look at, transaction recency by customer segment. So now we're going back to the original data, and we're looking at the recency value, which is the time since the last one played out. We'll do a box plot of all them. We can see the champions are all very low recency. So there's a certain amount of this should make sense because, that's how we created them. So it makes sense that there's none in the champions beyond 100 days because of the way we bucketed it. That shouldn't work. But what we can also then do is validate it by going to, and then we're just looking at the total revenue and the total transaction to count. So this is kind of in sample validation of the. But what we can also do is do the exact same thing based on the data after we did the modeling. So now let's look at, and we can do a churn percentage, which basically, I can't remember exactly how I calculated churn. It's all in here. But if you didn't make a transaction at all in the segment after that cutoff date, so now we're looking at all the data to the end of the data set from, I think, the 1st of April 2011. And if you didn't make a transaction at all, you were considered churned. So I'm just looking at the proportion of customers that were in that category that were considered churned by the latest one. And you can see here, like a very small percentage of the champions churned, whereas over, like in many ways, over 80% of them did. So I'm kind of doing a bit of model validation here by going, okay, based on the values, based on the data before this date, how do we categorize our customers? Based on these very simple combinations of quantiles, right? Then let's do some numbers based on those quantiles for the data afterwards. So like customer transaction count by customer segment. And we look here that the champions, so this is all after the date, looking at the most recent purchase, what's the transaction count? And we can see here, like champions in particular, you know, definitely stand out in the new data compared to the other categories. It's a bit more mixed when we look at all these here, but we can kind of see like loyal customers and potential loyalists. Remember, this is on a log scale. They're definitely standing out as performing a bit better, although maybe others are a bit more of a mixed bag too. And also the segment size. So I put the color here in as how big is the segment, just to get a sense of additional information. So we can see here that like that's the segment size. So these three ones had about 1,000 in them. So they're kind of in the red, whereas these need attention and others and about to sleep and at risk were smaller numbers. So that's why they're more towards the blue. And then we looked at total revenue. So again, we can see again a little bit more mixed, but definitely champions are very clearly being identified as the bucket we put them in are stronger. And even if you look here, because it's a box plot and it's on a log scale, there's not much difference in terms of total revenue between at-risk and loyal customers and others. Potential loyalists less so, but we're definitely seeing, you know, there's definitely some trends here with the champions and the loyal customers. Others are a mixed bag. Potential loyalists, not much to tell them between the others though, realistically speaking, like this one here and at risk and them. So basically there's definitely some, I don't want to say predictive value, but because we're not really making predictions here, but let's just say there's definitely some discriminatory power in this very simple approach that we've taken. We take all the data up to the cutoff date, which was the 31st of March 2011, which is there's two years worth of data. We basically split them into the buckets of total transaction, total amount spent, the recency, which was how many days or how many weeks since the last transaction, and then finally how many total transactions have been made in this data set up to this data point. Put them into these different buckets, which we, by the way, there is no basis for this creation. I used the one on this, and maybe we'll tweak this a bit based on the discriminatory power of these. So like there may not be a whole lot of value add in some of these. So maybe we either get rid of them or we, you know, or maybe we refine it a bit, maybe tweak it. And that's, to me, that's perfectly fine. I mean, there's, and maybe you could, if you really wanted to go hog wild and you wanted to go engineering, you could try and come up with some kind of discriminatory power. I don't know if it's worth it. I like the idea of, and this kind of is where the business sense comes in. You sit down with the business people, or you kind of, in our example, we're going to make some stuff up because we don't have business people to sit down with. But you kind of come up with these categories. And while this does seem far-fetched, I did exactly this with a client in the past, where we kind of had some very high-level things based on their knowledge of the business and what they cared about. And we just kind of drew broad lines to discriminate different customers. And then based on those, you know, high-level views of the customer base, let's look at some plots based on that categorization. And that's basically how Rfm models. No, they came out of the, it depends on what you mean, Robert. Do you mind unmuting for a second? So do you mean the categories or
the reference values there, the 3, 4s and 2s and the Rfm scores.
Hold on, let me go. So let me the segment definitions. Is that what you mean here?
Low values, high values, and that. Yeah, recency, upper,
Yeah,
upper,
yeah.
lower. Yeah.
So these
Yeah,
segments
that's it, sorry,
came
yeah.
out of the box. The segment, like, you know, what makes the fact that a champion is 4 or 5 on each, that came out of the box. That's part of the package. That, like, they have it in the vignette. That's how they make these definitions. The individual customer values are based on the data set. So like I said, you look at all the values of total spend per customer and you split that value up into 5 buckets. And then that customer is assigned 1, 2, 3, 4, 5, depending on where they fit on that split. So that is data driven in terms of where they come is probably reasonably robust, apart from at the very edge points where, you know, if you're at because it's a hard cutoff point. So, you know, there might be edge cases where someone is classified a 3 and someone else is classified a 4. And, you know, it's just a small bit around the bucket points. And there's definitely a problem there potentially, because you're creating these kind of very strong delineations between. But the flip side of that is 4 and 5 is probably capturing that. You might have customers in bucket 4 that aren't very different to the high end of 4 is probably quite close to the low end of 5, and so on down. So that might be one of the reasons why, you know, these kind of cutoff points might be kind of arbitrary. But these segments themselves were dictated by the package because I wanted to start somewhere. Now, maybe looking at it there, it's quite possible that some of these are not necessarily relevant for our data, and we might either drop them or redefine them or tweak them a bit based on what we're seeing here. And there's probably a little bit of back and forth on that. So we can see it here. Sorry, this is there is some missing customer segments where I think what I was doing here is just doing some check to see, are there people that aren't covered at all, and they're going into the other package, and into the other category, and what do they look like? So yeah, so I would probably tweak that a little bit, but like I said, the great thing about that is we can kind of, from talking to the business or maybe from ourselves, and I probably would look at that. I mean, because some of these just seem a bit like, I don't know, like about to sleep versus need attention. Like, let me see here. What's the difference here? Like, most of these are broadly the same. It's just that these guys are a slightly lower frequency and monetary, but they're the same recency. I mean, maybe I'd just combine them. So there's a couple of things we can probably look at that, and these seems very broad. So you've got very, very low. So it's a long time since they traded, but there's this broad bucket of frequency and monetary. So when you look at these definitions, it's let's just expand it out. I think there's only 10 though. Yeah, because this is looking at these, some of these do seem a bit kind of there's unnecessary discrimination here is the way I put. You've probably got a few many. Realistically speaking, maybe we only want 4, 5, maybe 6 buckets, one of which is an other. So yeah, that's definitely something. But like I said, you can kind of sit down, and it doesn't really matter how technical someone is. The concepts of this are relatively straightforward. You know, it's how long since you last transacted, how many transactions have you made, and how much money have you spent in total? Stick them into buckets, and which combination of buckets do we care about? And then those become our classifications. Okay. So that's basically where we are with Rfm models. And then I think I haven't really talked about, and I've gone on a while, and I'm conscious of the time because it's about 10 to. Let me very briefly explain how buy till you die models work. So basically, it's a similar idea as recency-frequency, but rather than using this kind of very simple kind of essentially what you would call exploratory approach, and certainly unsupervised, we're taking a statistical approach to it. So with buy till you die models, the idea here is that a customer is born when they come onto the website, similar to we looked with the RFM. So when the customer first transacts with the website, that's when they are born as far as the system. And then the idea is that they keep transacting at a fixed rate until they die, which is basically they churn, they go away. And there's various statistical models for this. So in one, essentially what happens is you have it like it's an exponential process. So you have a lifetime. So you're essentially at birth, you're assigned a transaction rate and a lifetime that you're going to survive. And you keep buying at that frequency until you expire with your, and essentially what the modeling does then is it tries to, based on the transaction data, it comes up with statistical estimates of that lifetime and that transaction rate. And as you can imagine, there's a certain amount of, from a theory point of view, they're independent of one another, but obviously the data would dictate that there's a certain amount of correlation between the two. And that's basically buy till you die. And there's a couple of different packages that we've talked about. I don't have time to discuss it today. I'll probably talk about them very briefly in the next workshop, just because they're handy to talk about, and they're worth at least knowing about. So you kind of have, it's measured by a dropout rate. So let's say, for example, I have a frequency rate of, let's say I'm going to make 10 purchases a year, or let's say, so you will have a per unit of time. So let's say it's a, so actually, yeah, let's do it. So let's say, for example, I make 12 transactions a year. That's basically roughly once a month, which is basically one transaction every 4 weeks, which is a frequency rate of 0.25. Like, this is really hand waving. So my frequency rate for transactions is 0.25. And then I have a dropout rate, which is basically every month, a certain percentage of the alive customers die off, i.e. they stop being your customer. So you measure that. Two ways of looking at that is you have a fixed lifetime and you transact until you die. Or the other way of looking at it is it like nuclear decay. Rather than looking at an individual lifetime, you look at the overall dropout rate. So on a per weekly basis, how often do customers drop off? And that's the other way of looking at it. So one way of looking at it is a drop-off frequency, which is this kind of dropout probability. But the inverse of this is a exponential distribution, which is essentially the lifetime. So you can either model it as a probability of dropping out on a, say, weekly basis, or the overall lifetime in terms of the weeks. And we basically estimate those two together. And it's because the probability of transacting, you transact at a given rate, statistically. And note that and this is something else that's important. The transaction rate is fixed, right? But that doesn't mean that you transact on a regular basis. Because if you look at any Poisson rate or anything like that, and you're transacting, that transaction won't happen on it's an actual exponential distribution. So even though you're not necessarily transacting on a very regular basis, that is still consistent with having a regular transaction frequency. So that's something. So that's just one like subtle thing to make. So like I said, we build up a statistical model from that, and we fit the model. Now, the problem I found with all these tools is the useful models can be hard to fit. So there is a simpler model called that has a more simpler assumption. And again, I don't want to get into it too much. I'll probably talk about it in the next one, because I think it's worth at least discussing, even if we don't necessarily use it for this workshop. I will discuss it in the next workshop. So like how you fit these and the various implications of the different models. But it's a similar idea to the RFM model. But like I said, rather than taking a really simple approach in terms of just cutting things up into buckets and putting people into buckets, we're instead making essentially distributional assumptions about, like, these things are distributed according to these probability distributions. And then we're using that data to make statistical estimate for the parameters of those probability distributions. Now, the flip side of that is it does mean that in many ways, when you fit buy till you die models, they're a lot more powerful, because they can be used. And interestingly enough, Raphael, it might be of interest to you, the original work on this wasn't actually really in a retail setting at all. It was actually done by people trying to make assessments about customers working for investment banks. So you had a bunch of I think it was Morgan Stanley, or it might have been JP Morgan. I think it was Morgan Stanley, though. They had a retail brokerage where, again, it's in a non-contractual setting. So you have customers that are going to make investment decisions. So they're going to call up their broker and say, I want to buy some IBM, or I'm going to buy some Microsoft, or whatever. And that's on a non-contractual basis. They would just call up randomly and then say, make a transaction. And they were trying, because it's non-contractual, they weren't sure if a customer just was no longer doing business and was no longer going to essentially generate commissions, or whether they just, you know, how do we get a sense in all that? How many customers do we actually are now alive, and should we get? So we kind of that was the initial setting for that. So it was actually done by, now it doesn't seem to be, I don't know if it's used at all these days, maybe it is, but that whole statistical framework has been taken out of that setting and now mainly is applied to like retail, to the point where some of these models are actually fit. I've seen that like there is buy till you die models are automatically generated by various machine learning libraries on the various cloud platform providers, presumably because they're just useful. Now, the problem I've had with them is they're a very interesting statistical model, but there's problems fitting them. And that's kind of a known problem. That some people have said they fit, like I've had problems fitting some of these buy till you die models on the data we've been working on. So that automatically makes me go to Stan, because Stan and the Bayesian approach gives you a much better diagnosis of that. But I don't really want to go into the whole Bayesian thing, because that would make this twice as long. Instead, I'm just going to deal with that in a future workshop. But yeah, so that's kind of where we are. So we've done a bunch of things. I'm very conscious of the time. I'm going to let this go now shortly. And if you have any questions, that's fine too. But basically, we've done a whole bunch of things now. We've looked at graph models. We've looked at association rules. We looked very briefly at buy till you die, which I didn't really talk about, but it's in. If any of you want to look at it, it's all in the repo, by the way. So if any of you have any questions before I actually get to talk about, by all means, look it up. I know it's just a bunch of random code, but if you see some stuff in there, I'm more than happy to talk about this. But the question is, what are we going to do? Like at this, we've kind of, you know, explored a bit now. We've got a sense of what we could do and what are we not going to do. So, and I went down a few blind alleys. Like I was looking at time series, and there is a couple of things we can do in time series. I'm just not sure how interesting that is and whether it's actually that useful. So we're kind of not going to look at that. I mean, it's certainly something we might revisit, and it would definitely be something we would put in the further work category of things that ways to extend this. But the way I'm thinking now is in terms of, we're going to do some proper modeling now rather than just dicking around and seeing what's possible. So what I'm thinking we'll do is we'll use this, we'll probably tweak these RFM models. And you know, we'll probably maybe tweak these definitions a bit and make them a bit more discriminating in terms of, you know, separating out the customer base. We're going to layer on some of the stuff we did with the association rules, I think, and go to Patrick's point about maybe looking at the various types of customers and seeing, is there commonality, not just in how much they spent, but in terms of the things they were buying. So are we finding that maybe customers that were more recent or less recent were buying certain types of products and then they stopped buying, and maybe there was problems with those or there was issues, you know, how does it, the other thing I might look at actually, because I haven't, is bringing in the returns and just looking at the returns versus the customer categories we've got, and also the returns versus the products. So I'm thinking what we'll do next time is we'll take our customer categorizations and we'll put all our customers into these buckets, having done a bit of validation like we've looked at there, probably a bit more validation. I'm not quite happy with everything we've validated with it so far. I think there's a little bit more we can do there. So that we're going to do that next week. Now in the next workshop, we're going to bring in the various clusters of products, and we're essentially going to look at like essentially contingencies across the two. So we're going to have like each customer will have a whole load of buckets that they've been put in. Those customers will buy products of certain categories and essentially collapse all those products down into the categories and just do the associations across the two and just see what we can get from it. And essentially, what we would like to do is identify for the more valuable, probably the most valuable and the least valuable customers, and look at the products that they buy or the products that they didn't buy, or maybe the products that are in the same categories as the product categories that they haven't purchased, and maybe try and give offers that way, and maybe for a loyalty program. But I think we're going to focus on like customer value, I'm thinking, and just maybe in terms of the products that those customers might buy. And that's kind of what we'll do. So in the next workshop, we're going to essentially have a worksheet that does the modeling part of that and looks at the various models. And once we're done with that, and we've got that done, probably this, I'm thinking there's 2 more workshops, but I don't want to talk too fast because maybe there's 3. the final workshop then will be just putting all this together, maybe discussing a shiny app we may have built, maybe, talking about some key findings. Maybe if we find something really interesting, like look at these customers here and what they do and where they bought and the type of, maybe the time they were buying, or what can we do about them, and essentially do that, and then we'll tie a bow on it, and we'll call ourselves done. But yeah, I've kept you till 9 o'clock, which is later than I usually go, but I was very kind of late starting on all of this. So thank you very much. We will be back next month because it's August. I don't know if the weather will be quite as nice. I'm surprised 8 of you managed to stay on for this long, to be honest. I hope you found it interesting. Like I said, we don't have a proper talk in August. The next speaker will be in September, the guy talking about boosting. So I probably have another workshop on this, on the modeling. I'm not sure I'll have a workshop in September. It depends on whether we might actually have a few speakers in the autumn. So maybe we'll have 2 events. I don't really know yet. I haven't decided yet, but we're getting to the end. We're actually getting close to something. I know it's a bit of a mess at the moment because we've just tried a bunch of things. What the next workshop is going to essentially focus on is, how do we take all the kind of exploratory stuff that we've done, and how do we create effectively like a model narrative for ourselves and do that. And that's kind of an important part of it too. And then the final one was, how do we translate that thing that is clear in our heads, and how do we turn that into something that essentially a deliverable, or something that someone who isn't technical can understand. And that's essentially going to be and these are all very important things. They're probably more important than the fun stuff we've had in the last couple of weeks, last couple of workshops, which I thought have been quite interesting, but I certainly couldn't present any of this to a stakeholder, because what the hell is all of this nonsense? Okay. But thank you very much for that. What I'm going to do now is the standard, thank you very much, Caleb. I'm glad you found it useful. Yeah, but I mean, if there's anything you disagree with, by all means, let me know. I mean, I am by no means, an expert on this stuff or the be all and the end all. Like Patrick, like I said, some people have came up with some very good ideas. Some of the stuff I've been showing you have been like from random suggestions from people in earlier workshops. Yeah, data storytelling, it's hugely important, Raphael. People are talking about it, but like, I'm not entirely sure what it means, but you do need to be able to at least know what you're telling people. And then you figure out, how do I tell that story? And it's not really a story in terms of like the hero winning, but you want to give a message, and how do I convey that message? And sometimes it involves just repeating yourself a lot. So there's nothing wrong with repeating the same message in 3 or 4 different ways, because there's the old joke that I heard Tony Blair once said, when he was in government. He said, only when you're absolutely sick to death of repeating yourself over and over again does the public finally start to listen. And that might be very self-serving, but I find it's very true. Like, I found myself repeating the same messages over and over again. And it's always very fun when people start telling you back what you've been saying for 5 years, and they're telling you as if you're hearing it for the first time. They think they're telling you something new. That's both equally frustrating and great at the same time, because it means people are finally getting the message, which is great. But I am going to stop here now. I'm going to stop the recording. Hold on. How do I do that? I'm going to stop the recording now.